Hello everyone, myself Dr. Hemakumar. In this session, I will be discussing about recursions. Definition of recursion: function that call themselves to solve a problem in small chunks. In C++, a recursion function is a function that call itself either directly or indirectly until a specific condition is met. This technique is used to solve problems by breaking them down into smaller, self-similar sub-problems. Key components of a recursion functions are that base class and recursion steps. Base class. This is a terminating condition that stops the recursion. Without a base class, the function would call itself indefinitely, leading to a stack overflow. The base class handles the simplest instance of the problem where no further recursion is needed. Recursion steps. This is a part of the function where it calls itself with modified arguments, moving closer to the base class with each call. The problem is broken down into smaller instead of same problem. Example program factorial of calculating the factorial using recursion. The factorial of a non-negative integer n, denoted as a n exclamatory symbol, is the product of all positive integer less than or equal to n. For example, factorial of 5 is equal to 5 into 4 into 3 into 2 into 1, which will become 120. Example, how we are writing the code. Observe this code. Integer factorial of int n, open bracket. If n less than or equal to 1, return 1, else return n into factorial of n minus 1, close the bracket. In this function, the factorial is the name of the function which is called by itself, but the parameter is modified or reducing by itself. So beginning earlier it was n, next time it will be n minus 1. It reduces till it become a 1. When it become a 1, that is a base class, reaches the base class, then it in work in a reverse order and it will complete the output. When to use recursion? Recursion is often suitable for problems that can be naturally expressed in terms of smaller identical sub-problems such as tree and graph travels, divide and conquer algorithms, example for that merge sort, quick sort, etc. Mathematical problems like factorials and Fibonacci series, and backtracking algorithms. These are the major uh, way we are going to use the recursion. While writing a recursion program, we need to consider the stack overflow, performance, and readability. The stack overflow means excessive recursion depth can lead to stack overflow error as each recursion call adds a new frames to the call stack. Performance. Recursion solution can sometimes be less efficient than iterative solution due to the overhead of a function calls. Readability. For some problem, recursion can lead to more conscious and elegant code, while for others, an iterative approach might be clear. In C++ program, recursion involves a function calling itself to solve a problem. The types of recursion can be broadly categorized as follows: direct recursion and indirect recursion. In the direct recursion, this occurs when a function calls itself directly from within its own body. Head recursion. The head recursion is the first operation in the function before any other processing or calculation starts. Tail recursion. The recursion call is the last operation in the function and no further processing is needed after the call return. The tail recursion can sometimes be optimized by a compiler to eliminate stack overhead, making it behave like an iterative loop. Tree recursion. A function makes multiple recursive calls within its body, leading to a branching structure resemble in a tree. The Fibonacci series calculates a common examples. Nested recursion. A recursion call is made as an argument to another function call within the same recursive function. Indirect recursion. This occurs when a function calls another function and that function, second function or a subsequent one is a chain. Eventually call the original function forming a cycle of a call. For example, function A calls function B and function B calls function A. Why is recursion in C++? Recursion is a method in C++ which calls itself directly or indirectly until a suitable condition is met. In this method, we repeatedly call the function within the same function and it has base class and recursive condition. The recursive condition helps in the repetition of the code again and again and base can help in the termination of the condition. If there is a no base class in the recursion function, the recursion function will continue to repeat continuously. Example for this, integer recursion of an open bracket if n equal to 0 return, else return n minus 1. Here n equal to 0 is the base class that will terminate the iteration of function when n becomes equal to 0. Return n minus 1, the recursive function that will help in repetitive of the code. Why do we need recursion? Recursion can be used in almost every problem, but there are some cases where the recursion is actually helpful. It is generally used when dealing with complex problems and problems that form a hierarchical pattern. It solves the original problem via smaller subproblems. Working of recursion. Recursion perform a number of repetitive calls to the function from within the function. The recursion condition perform the repeating calls to the functions until the base class is met. The base class is present inside the function and once the condition of the base class is satisfied, it stops the execution. It is assumed that an example to find a factorial of 5. So return 5 into factorial of 4 into return 4 into factorial of 3, return 3 into factorial of 2, return 2 into factorial of 1, return 1 into factorial of 0. When n becomes 0, it will terminate. So then it goes up, 1 into factorial of 0 is equal to 1 and 2 into factorial of 2 will become 2, then 3 into factorial of 2 will become 6, 4 into factorial of 3 will become 24 and 5 into factorial of 4 will become 120. Like this the program will be executed. In a given example, finding the factorial of function, we have to perform many repetitive calls to function. In this example, recursion condition would be n into factorial of n minus 1. Factorial is a function name and the value of n is 5. First in this function 5 will be multiplied with the factorial of 5 minus 1, then 4 is passed to the function. Similarly, in the next iteration 4 is multiplied with factorial of 4 minus 1. This will continue till the value of n becomes 1. Please note that direction of the function can be top to bottom, that is factorial of n minus 1. Here the printing of code is done before the recursion call, bottom to up factorial of n minus 1, cout n. Types of recursion: direct recursion, indirect recursion. Direct recursion, in this direct recursion, the function calls itself directly. Indirect recursion, if a function calls itself indirectly from another function, then this type of recursion is called as an indirect function. For example, you can see this slide, wide direct. In the direct function itself, direct is called, that is a self calling, so it is a direct recursion. In an indirect recursion, we have written the example, wide indirect function we will call wide function. This function is calling a indirect function. So function indirect is calling a function and function is calling indirect. So two different function, indirect and function, are calling interchangeably. That is called the indirect functions. Demo program. In this function, example program, we are find the sum of all digits up to a particular number that is entered by the user with the help of a recursion. First line we were going to write hash include IO stream using namespace std. Int sum of bracket open bracket integer num. Parameter is passed open flower bracket. If num is not equal to 0, then return num plus sum of n num minus 1. Else return 0. So this is the sum function. Then we call as the integer main function integer num. Cout enter the number. C in num. Cout sum is a sum of num. So assume when the a sum of num is called, the function jump to the sum function and it runs with a recursion technique, and it will output will be resulted. Then return 0 because the main is returning a integer type of value. Thank you.